Hello, my name is Rebecca McNeil, and I'm a first-year MPH Global Health student. Today, we'll be discussing an interdisciplinary approach to the dilemma of lead-acid battery recycling. This presentation will include objectives, background, three different perspectives to approaching the dilemma, assessments of these approaches, and lessons learned. The objectives of this presentation are to understand the health challenges related to lead-acid battery processing and recycling, to understand the financial incentives for families to continue to process LABs, to observe the different interdisciplinary approaches to addressing the problem, and to learn the benefits of an interdisciplinary approach to public health dilemmas. In looking at this issue, lead-acid batteries are the most widely and commonly used rechargeable batteries in the automotive and industrial sector. These batteries are used for cars, trucks, buses, as well as wind turbines, which are gaining popularity, backup power supplies, cell towers, which are very prevalent, especially in the US, and more. They can last anywhere from 3 to as many as 12 or more years. And when these batteries die, they may be recycled or disposed, ending up in trash dump sites around the globe, even if they are produced in high-income countries. As the global demand for renewable sources of energy increases, the value of the materials in these batteries also increases. As a result, there is a demand for the material in these batteries to be reprocessed and sold back to the industries that need them. However, in many low and middle income countries, there is no regulation for how this is done, so individuals can do this on their own. The process typically ends up being as follows. A sharp tool is used to open the battery casing, as we can see in this photo. Contents of the battery are dumped out, including lead and sulfuric acid, to whatever surface that they're being used on. Contents are burned or smelted to create lead bars, and then these bars are sold to battery companies that want the materials. Various health and environmental problems can result from this process. For one, the burning process releases lead dust into the air, creating pollution and exposing the surrounding community to lead poisoning. Leftover contents are dumped into unlined pits and waterways, meaning that they are not contained and can leach into the soil and water supply and spread to other communities. Additionally, when used batteries are initially discarded into trash dumps, they can split open and contaminate the soil. Families that live near these sites, including children who play nearby, are thus exposed. So why not just ban these batteries altogether? Well, there's a couple of reasons. For one, these batteries themselves are still considered a valuable resource for energy, and even countries with regulations are not ready to give them up. Additionally, the process of recovering lead acid batteries and creating lead bars is a valuable source of income for many families in low and middle income countries. The value of lead is now $1 per pound, making this process profitable and significant for individuals living in poverty and looking to provide for their families. So now I'll look into three different interdisciplinary perspectives and see how people from different work backgrounds and fields of study would approach this problem. The first person I discussed this dilemma with was Amanda. Amanda holds her master's in social work and currently works as a social worker at a school and works with the students there. Amanda focused on the people that are processing these batteries and proposed a system to analyze and prove whether or not batteries are being processed safely. This approach is similar to other industries that have begun marketing their products as ethically sourced, such as the diamond industry or even the chocolate industry, which has begun labeling their products if they're ethically sourced, and consumers are often willing to pay more for these products. Using this approach would increase the value of materials that are processed safely. And taking it further, a reward system could be designed that could help to incentivize the proper handling and processing of these batteries. Altogether, these efforts would provide better compensation for the families involved in this industry. The second person I talked with was Danielle. Danielle is a software engineer who works for a nationwide company that provides mental health services for clients. I wanted to acknowledge a comment she made that demonstrates a true understanding of this issue. She expressed concern and said it's another example of lower income nations paying the price for higher income nations' development. Danielle's approach focused on promoting proper personal safety measures for processing lead acid batteries. She proposed designing and constructing facilities where batteries could be processed safely and pollution could be controlled without impacting the community and environment. She discussed providing PPE along with education and training for those utilizing the facility so that workers could remain safe and healthy during the process. The education approach would be beneficial beyond the work in this facility. Lastly, acknowledging that this process would not be cheap, Danielle proposed that high income countries work to pass legislation requiring industries and companies that produce lead acid batteries to help fund these recycling facilities or at least provide some direct aid. This approach pulls high income countries into the problem and holds them accountable for their contribution to this crisis. Lastly, I talked with Lauren. Lauren is a mechanical engineer with a background in aerospace engineering. Lauren's first approach was to explore the options of redesigning batteries in a way that the lead inside can be easily extracted. This would allow processors to remove the lead without messing with the other materials. She then proposed a government subsidy or incentive for turning in leftover contents to a safe disposal site. In urban areas where this may be happening more frequently, safe disposal sites could be set up around the city. This initiative could be paired with public education about physical and environmental health. Lastly, she discussed the possibility of designing safe disposal kits that could be made available for people working in this industry. These kits could provide PPE and could contribute to containing the leftover materials. After considering these approaches, some common themes emerged. There was a strong focus on the safety, health, and protection of the people involved in the recycling process. There was a call to pull in effort from high income countries and hold them accountable to the part they play in this dilemma. A theme emerged of providing incentives for safe and ethical processing of the batteries. And lastly, there was a proposal to reassess the design of lead acid batteries to find a way to make the lead easily accessible without exposure to other materials. I want to highlight this last point because it really is a way of going back to the drawing board and seeing if is there a way to redesign these batteries to stop this problem from happening in the first place. Overall, this project was fascinating to take on. An interdisciplinary approach allows us to pull opinions from others working in different fields to create a wide array of ideas. It promotes creativity and problem solving and allows for inclusion of perspectives that are unique and specific in addressing these massive dilemmas. And overall, it increases awareness of a public health dilemma that impacts so many and demonstrates that anyone can contribute to solving these problems. Thank you.